API, they kind of pose a kind of different or unique challenge when it comes to security as compared to, so we look at traditional security, and then we look at cloud native security, and then we look at API security. So talk about, what makes it a bit different, and why, you cannot just take, some random off the shelf traditional tools for API protection.
Such a great question. And it is something that is not always obvious that it would be this way. So Swapnil, you and I first got to know each other when I was with a container and Kubernetes security company. And what was interesting was that the way that we were developing applications had changed. But at the end of the day, attackers didn't attack containerized apps any differently than any other app, because they didn't know that it was containerized or, running in kube. And the attack mechanisms really didn't change. What changed was you had to think about how you configured your containers in a protected way and things like that. But you didn't change how you attacked apps. That's not the case with APIs. And I think that that's a profound realization. When people are looking to attack applications this way, they are very consciously thinking about how APIs work and specific mechanisms to manipulate API calls to break through to this new, get to new sources of data or do account takeover, within that, then launch a credential stuffing attack, that kind of thing. So because you attack differently, it shouldn't be a surprise that a lot of the existing tech can't see it. And it's important to just take a couple seconds and think about what an attack looks like. Most of the time that we propagated application attacks, we followed a known pattern. I'm going to try SQL injection and see if it works. I'm going to try cross-site scripting and see if it works. But it's very one and done. I'm just going to do this transaction, and if I'm lucky, I'll find a point in your code where this known attack will work. You can build technology to look for those known attacks relatively easily. It's isolated to a single transaction, and it's following a known pattern. Definitely not the case with APIs. First off, there is no way for it to follow a known pattern per se, because your APIs are different to my APIs. And so the way somebody would attack your APIs is necessarily different. So first off, you've got to learn the API to learn how to attack it, and you're going to attack it differently. The second thing is it takes a while to figure this out. It takes a while to build that picture of how these APIs work and therefore how I'm going to attack them. And that means your defense mechanisms have to be different. Your defense mechanisms can no longer look at one transaction at a time and have an accurate view of what's going on, because that API attack is stitched together over time. It's a lot of different steps over time. The guy who put all zeros for Experian for a birthday, it wasn't the first thing he did. It was probably the 39th thing he did. So what you need is context over time to be good at API security. And in turn, what that means is that you need a lot of data. You need to be looking at a lot of data over time to see an attack that could take weeks to propagate. So that also means, you're not shoving this in a little VM, sticking it on-prem, and you're all good. It's not going to happen that way. You can't hold enough capacity in a single device like that sitting in your prem to be really good at API security. So know that the attacks are different. Know that your tooling, you didn't make a mistake. You didn't buy the wrong tooling. It's good for other attacks. It's just not good for API attacks. And then understand the role of big data, AI, and ML in stitching together activity over time to understand an API attack, to detect and understand and block an API attack.